Hello and welcome back to another video. Today we're going to be taking a look at this Toshiba Libretto W100 or 105. This unit has a bulging battery that luckily I caught just in time a while back. It was just stored away in the box, and although you think that may be a safe thing to keep it all squirreled away and it's a box somewhere, unfortunately I had caught this just in time, but the battery had started to bulge pretty badly and was already causing some pressure on the bottom screen. The battery is kind of necessary to keep the machine balanced. Without it, it does tend to just fall backwards, so I'm just using the battery here to hold it up, just to get it on display a little bit. But I think we'll go ahead and try and open up this battery and do a swap of the cells. At the very least, I'll end up with some sort of a battery that provides enough weight for the bottom of the computer. But hopefully we'll be able to actually find replacement cells and get the battery working again. So let's get right to it. Okay, so shut down the little libretto here. And actually Clint LGR did just a really fantastic video about this machine, and it's one of the reasons that I decided to go ahead and get mine back out and finally get around to this repair. So if we take a look, mine is actually the 105, and it is the American version, and I believe Clint's was the European, and this one, to my knowledge, does not have the built-in cellular. It does have the same configuration of ports, so I do have a micro SD card slot up here on top, and there is some Wi-Fi battery indication here on the side, and then the same ports for audio and USB. So let's go ahead and get this to the side and take a look at the battery, and it's kind of hard to tell, but it is bulging right here in this area, and it makes it pretty much impossible to get into the machine. I think at this point, if I tried to insert the battery, it would probably crack that bottom screen. So again, just very lucky that I caught this. And a great tip is to go ahead and, if you have a laptop with a removable cell, especially if they are the flat pack lithium ion batteries, the 18650 or the circular variety don't tend to bulge. I've never seen that happen. But with the flat pack batteries, that is certainly a possibility and can be very destructive. So let's see what we can do to get this battery apart. Okay, I have the little metal spudger here, so I'm going to try and get under these clips. What's concerning though is that the side doesn't even want to seem to separate. So it just makes me think these clips are not doing much, if anything at all. So let's see if we can start to pry. Yeah, I don't know if it's sonically welded, but that is certainly a lot of pressure. I do hear some cracking, so that might be a good sign. So we might just be able to run around this edge a few times and eventually get these covers separated. Okay, so I'm going to do more of this off camera, and I will report back with how this goes. I'm just going to plan to use this spudger along all of the edges that I can get access to, and hope that is enough to start separating this cover. Again, I just want to try and preserve as much about the cosmetics of this battery if possible. Worst case scenario though, it doesn't look like we'll have any damage to the visible portions of the battery, at least when it's installed. So I'm going to do that and report back. Okay, some progress. I was able to separate along this top edge with the spudger. It was not easy. I was also able to start separating the sides a little bit as well. So just some tips before we go any further is that, yes, it does seem to be slightly sonically welded here at the top. You can see a little bit of evidence of that. The two major points where this was difficult was getting the spudger in between here and here on either side of the battery clips. This was just a very tight place to get into. I kind of had to start from this side and this side, and then I was able to get under here, and then I was eventually able to, this one was a little bit easier and this one was quite difficult. Okay, so moving on, we do see that it's separating. Okay, and then as we start to open this up, we can see some of the batteries inside, of which there are 4, and it appears that 2 of them has started to bulge over here on this side. And then I was able to separate the sides over here a little bit by getting the spudger just under the edge and applying a little bit of a prying pressure. So it is going to still be difficult, whatever is going on in this edge, to get that to release. But let's see if we even have to take it apart that far. We may actually be able to get the batteries and the electronics out. So let me see if I just hold this open, and I'm very hesitant to put any prying force on the actual batteries themselves. I definitely don't want to cause a short. So let's see, the board appears to be attached to the batteries. So I wonder if these are glued in. They probably are, or at least some sort of adhesive. So let me get a plastic spudger. I don't want to cause any shorts. Okay, I got a couple of plastic tools here, not the greatest. If anybody knows of things that may be better for this, definitely let me know down in the comments. Something like this that has a good amount of force that you can apply to it, but just non-conductive. So let's see, that's just wire. We need to get our prying tool under the cells somehow, but I don't see a great way to do that. I don't know. Maybe able to start from the side here. Again, it would be great, and it looks like the case is actually starting to crack a little bit here. So I don't know if I can get this to release any further. There, it's a little bit. So what I want to do is get under there with one of these tools. I imagine if one of these batteries starts to pop out, the rest will start to follow. Okay, that's starting to release a little bit. Probably get out the heat gun, but at this point I don't think any additional heat is going to do these batteries any good. So I definitely don't want to start a fire. Okay, I'm gonna risk it for science here. I just need, again, a little bit more prying force underneath these batteries. Oh, there's another battery. I'm prying against a battery. Okay, we gotta... Okay, so there's 8 batteries in here. That is a bit of a development. So it looks like we were just separating the battery cells from each other, which is not what we want to do. Yeah, I don't know. The only choice may be to get this cover completely off, and it does not want to do that at all. Okay, so I was trying to, I think this whole cover needs to come off, so I was trying to pry up from here. I don't love this position, because I don't want to damage. Okay, so yeah, there's some sort of a clip system going on here. Okay. Yeah, this is not a lot of fun. Okay. So. Oh, okay. Finally off. All right, so now we can get a much better look at these batteries. Yeah, wow. There we go, just adjusted the brightness a little bit there. So yeah, now we can see these batteries and we can see how badly these packs over here are bulging compared to these cells, although these are starting to bulge a little bit. It's a little bit different of a battery cell than I was expecting. I was expecting the lithium polymer style flat packs. So these are a little bit different. But let's see if we can go about getting these separated from the bottom of this battery. Okay, well, just broke my prying tool. Okay, get that out of there. Okay, so yeah, I really don't love getting the metal tool in here, but if we're careful, this may be the only way. So if we go really slow, the glue should start to release. So we might have to keep trying at this for a few more passes. Just see if we can get that glue underneath the battery, or adhesive tape, whatever it may be, to release. You can hear that sizzle sound. That is that's the glue, not a battery about to explode, I sure hope. Let's just keep at it. It is starting to release, so I'm just going to keep doing this for a minute and see if I can get all the way down this row. Oh, there we go. So that battery just popped up, but we need the rest to do that as well. Man, this battery is not going to give up without a fight, huh? See, I'm a lot more worried about getting the metal spudger here under these contacts, because this is where they'll have different contacts that make this a complete pack, whereas here on the side it was just this one kind of lead running this way. So yeah, let's see. Let's keep going. I may have to keep going underneath the other batteries. Pry them up like so. Okay, that's working. There we go. Okay, so we have the pack completely removed from the shell. So now we can kind of take stock of what we have going on. So these cells are bulging way worse than I thought. In fact, it looks like this one has broken free of its connections over here. So yeah, even if this pack was working, it was not working at full strength without one of these cells. Okay, so I think the next thing to do is try and get some good pictures for the connections and start disassembling safely this pack and see if we can go about finding replacement cells. Okay, so battery has been disassembled successfully. I only cut myself a little bit. So the battery was quite difficult to remove, lots of tape, lots of very precarious situations in trying to pry off the welds on the battery contacts. Most of these I was able to save pretty much intact. I may be able to reuse a lot of this. This one component, most likely some sort of a fuse here. This was already broken inside of the battery pack. It had broken off of its terminal on this battery. Here we have all of the packs. As you can see, very bulgy. So now we can get a much better view of how bulgy these batteries are. So what I did when I went through this is I also labeled the connections, and it appears that 2 connections here go to the first negative, which actually makes sense because the battery pack needs to be able to charge the battery, so it's most likely charging it through this contact here, but then it's using this outside contact for the actual delivery of power back to the laptop. So this is a kind of another fail-safe fuse. Which could actually mean that you could charge the battery pack, but you would not be able to get any power out of it. So I've labeled these as 1, these 2 both go to the first negative, and then each one of these goes to E positive or the negative as the batteries are just all in series. So here we have 2 connections to the first negative. Here we have the first positive, so 1, 2, 3, 4, and 5. And those are all of the necessary connections between each of the packs and each of the cells that we'll need to be able to restore to get this battery pack up and running again. Another interesting thing is the battery PCB here is fairly simple. It looks like there's a number of components. Either these are diodes or transistors most likely. And then we just have 2 chips here, which I'll try and get a zoomed in shot. Oh, there's actually a little third chip right there. But I'll try and get a zoomed in shot and see if I can get the model numbers from these so that we can actually look up the data sheet. But otherwise, I think the safest bet is to try and find exact replacements for these cells, because this battery was manufactured to the exact size of these cells. There's even these little clips here that go around the battery and shield the positive terminal. So it looks like the battery is completely bare, and this little shield would go over and protect the positive contact on either side of the battery. So we'll have to probably transplant these back to the new cells and go from there. But so I think we'll do some research, try and find some replacement cells, and we'll be back soon. So before we move on, I thought it would be fun to just take a look at these batteries under the voltmeter and see if they still had any charge. So I'm going to go ahead and hook up to the negative here on these 2. These are some of the non-bulging batteries. 0.8 volts in the negative. Is this actually the negative terminal of each of these batteries? That's interesting. Normally the outside is the negative. These are both reading. That is very strange. Let's take a look at the other non-bulging batteries. So if I get my lead here. Huh. Yeah, 0.6, but these are also negative. I mean, I'm sure I have the voltmeter hooked up correctly. That is interesting. I wonder if these are all like that. Oh, wow, these are completely dead. Wow. That is not good for a lithium-ion battery. That is for sure. Yeah, these are nearly completely dead. Wow, all right, so I guess that certainly explains why we're seeing so many problems with this battery. Is that the cells are completely dead. So, all right, let's find those replacements. And we're back. So I have the disassembled battery here, along with the controller PCB. This is the empty case of the battery, and here's all of those old cells, still quite bulgy. Definitely need to dispose of these soon. So I wasn't able to find exact replacement cells. For anyone who is interested, these are F1134 cells. They are made by Sanyo, these cells at least. There could still be some that are floating around on the internet, but I haven't been able to find enough replacements. You know, if it's $10 or $20 for each replacement cell and I need 8 of them, that's going to be rather expensive. So I was able to find some somewhat replacements. So these are 70, 40, 60 cells. So that's 7 centimeters, 4 centimeters by 6 millimeters thick. And that's just how the numbering scheme, model numbers, whatever you want to call it on these typically work. They're pretty close, but they are by no means an exact match, so they are relatively the same physical size as one of these cells, but a little bit thicker. So I'm only going to use 4 of these. In the end, that means that these are rated at 2000 mAh. Not really sure if that's an accurate claim on the battery here. But the original Toshiba battery is labeled at 2360 mAh, so it'll be a little bit of a reduction in battery capacity, but I'll happily take a small reduction in capacity for a working battery pack. So I think the first thing to go about doing is that after looking at this for a little while longer, I realized that I made a couple of mistakes here. One is that this is the positive side, so this is the main positive input on this PCB, and on this side is the negative. And however, this one is not the 5th terminal, this one is the 5th terminal. So, because if you actually look at this this terminal here, this is what bridges the connections in between 2 of the packs, or the 2 sets of cells. So I'm going to wipe these numbers off, renumber it, and relabel it just so that I can keep track. And then I'm going to go ahead and remove the terminals that are on here, but I think I'll leave this one over here just because it has, what appears to be a fuse here and potentially another fuse or thermistor over here. I'll probably just leave this entire section intact here just to keep those components in play. The things I'm concerned about, though, are the original terminals on here have fuses for each of the connections on the batteries. A couple of these are a little bit worse for wear, and even if I do get out the spot welder, I'm just a little bit worried that these contacts are just a little bit, damaged from all of that use. So I'm hoping that the protection circuit in these cells is adequate. One of the concerns that I have is that these wires are kind of thin, and it would be a little bit of an effort to open up each one of these and solder on larger wires. So I'm going to go ahead and try it with the smaller wires. The little Toshiba doesn't pull that much current to run. It's not like I'm running a bunch of external hard drives off of this machine, so we're going to forge ahead and see if that works. Another thing is that these batteries do have an additional terminal. I suppose this is for a built-in temperature sensor within the battery, so we'll probably just snip the white wires off or put them out of the way. But otherwise, we do have our positive and negative terminals here on the battery. So let's get to wiping and relabeling this, and we'll keep going. Okay, so numbers wiped off. A little bit of alcohol just takes that right off. So they are actually numbered on the other side. I'm not sure how well that's coming through. So I think I'm just going to mirror the same numbering scheme that is going on the other side of the PCB here, but we'll go ahead and label this as our positive side. And let's see, so this one is 1, 2, 3, and then number 4 is actually all the way at this side, and that's kind of what tripped me up last time. And this one is number 5 over here, and that is our negative. So our positive is over here, and our negative is over here. Okay, soldering iron all heated up. Let's go ahead and remove these extra terminals. So this should just come right off with a little bit of heat. Okay, so there's one of our terminals removed. Okay, so that is all of our battery terminals removed, just still keeping this one on this side because it has some additional components that we'll utilize. But there is our stripped down PCB. And here's our main connection points for all of the battery packs. Okay, and then so here we have the PCB back inside of the battery case. So one of the things that we're going to need to do is remove just a little bit of plastic around where these terminals are so that we can fit our wires up under here. I'm not going to solder them onto the top because that's where the top cover goes and there's very little clearance, so they've actually etched out a small area for this temperature sensor here to fit into. So we're just going to notch these out and get to soldering. Okay, so a few little channels cut for our wires to fit up under our PCB here. I think it's time to start connecting things. So the way that these batteries will fit back into the case is like this. So there's a perfect amount of clearance. They are just a little bit less wide and a little bit thinner than the cells that were in here originally, so we should have plenty of room. Okay, so I'm going to start by connecting this first battery, and I think I'm just going to go ahead and trim this white wire a little bit short. There's just really no reason that we need it. So let's cut that off and carefully expose our terminals here. So the first connection that we need to make is to this number 5, so this LP5 terminal point, and that's where we'll connect our first negative wire. So we'll go ahead and solder that onto our board. And I think I might do this from the opposite side. So we'll just orient our battery. That makes sense. Okay. So our first terminal is the LP5. So that's where we'll connect the first negative of our battery here. Go ahead and solder that into place. Okay. And then the next connection that we want to make is to start with another one of the batteries. So again, I'm just going to go ahead and trim off this white wire. It's just going to get in the way. So we'll carefully clip off our white wire. And we will expose the next negative and our positive for the current battery. Okay, just be careful to keep all of this as isolated as possible. So we'll orient our battery in the same way, and then both of these wires will connect to this LP4 terminal. So just hold these together and get that soldered on. A little bit of room for myself. Might do this diagonally. Okay. Okay. So that is our battery starting to be connected. So the next thing we want to do is take our next positive wire and our next battery cell, and we'll go ahead and trim off the white wire. Get that out of the way. Orient our battery in the same manner. Okay. Expose our negative wire and our positive wire. And these two will connect to this LP3 terminal. So hold those together and get that connected. Excellent. All right. moving right along. So we'll get our last battery cell here. Go ahead and trim off that white wire. We'll expose our next negative connection. And our previous positive. We'll hold these two wires together, and we want to connect this to this LP2 terminal. So we'll get those centered up. All right, that is connected. And our last connection here will be to this LP1 terminal. The way that this contact works is it just snakes around. So if we just connect our battery here to this LP1 terminal, the positive will make its way through this little circuit here and back to the main positive input that is over here. So we'll just go ahead and expose our last positive. And we'll go ahead and get that connected. All right. I believe that may be a functioning battery pack, but we'll have to put it back together a little bit and do some checking, and then we'll plug it back into the Libretto and see if we have a success. Okay, I have the voltmeter out, so we're just going to do a little bit of sanity checking between our terminals here. So we'll start at our main negative, go over to our first pack, so 3.9 volts. And then we'll measure in between the packs. Another 3.9 volts. We'll keep measuring between the packs. Another 3.9 volts. And our last pack, 3.9. And then we're just going to check to make sure that we have the expected voltage out of all of the packs. So there we go, 15 volts. That looks good. Excellent. Well, I think we're ready to go ahead and put this battery back into the case. So for getting this back into the case, we're going to want to be a little bit careful. There's obviously a lot going on here, and we don't want to short circuit our batteries. So I'm going to pick the whole thing up by the batteries, flip it over, get this oriented properly, and let's see if we can go ahead and get this back into our case. Just kind of drape our board on there for now, and we'll go ahead and start getting some of our batteries stuck back in here. I will put these down with some double-sided stick tape once we know that the battery is actually working properly. So we'll just keep getting our wires out of the way, get our battery packs inside the case. These do fit in there. They don't always want to. There we go. So I just don't want them sitting on top of the wires. Wires are a little bit crazy in here, but we can clean this up in a little bit. Okay, and looks like this battery's good. So what I might end up doing, I think I might want to trim the rest of this material away. There's not really a great way to do that now that it's assembled, so I'm just going to use the scissors on my pocket knife. So sorry, pocket knife scissors, but this is the duty we need from you today. All right. Okay, so that should make that fit in there a little bit better. And actually, I don't see a reason why we can't bend this up a little bit. So we can actually make that a bit flatter. Okay. So then we can scoot this battery over just a little bit if it wants to. This is pretty fiddly, but I think this is gonna work. Okay. So now we just need to snake our wires underneath this lip here and through our little holes that we put into the plastic. So these 3 wires need to come out of this hole. And then these 2 wires will come out of this one. It looks like... Okay, and just the 1 wire comes out of this side. This feels like it's hitting something. What's going on underneath there? Nothing, okay. That seems fine. Okay, it's a little bit precarious, but I think I want to go ahead and try plugging this into the Libretto and seeing if that actually works. So let's give that a shot. Okay, it's a moment of truth time. It is a little bit precarious. The cells are not, you know, glued down or anything at the moment. Everything's a little bit loose, but I think if we're careful, we can get this battery inserted into the Libretto. So we'll just hold this very, very flat. And I believe that's connected. So I don't know if these batteries have enough charge to start up or if we've caused some other damage, but let's see if the Libretto will start up. Okay, I did actually see the light come on for a second. Oh, it's on. Oh, it works. Yes! Great success. So our batteries are in here working. I think I might let it try to boot up here and just see if we can check the current capacity. I don't know if... Let's see, I did press the home button. I guess the BIOS is a little bit slow here. So we'll let the Libretto boot up, check our battery power, and go ahead and seal this battery back up. Okay, so the Libretto is on. It's a little bit hard to see here with all the glare, but the battery says it has 3% remaining. So what I think I'm going to do is go ahead and plug in the power cord and let this charge up for a while. And hopefully that gives us a full charge and I'm able to use the battery a little bit, and then we'll seal it all back up and call this a success. Okay, so the Libretto's been running on battery and charging and discharging just fine. I've put it through a few cycles here just using the piece of freeware battery info view. It's pretty nice. It gives you kind of a table log of the battery capacity either charging or discharging over time. It also gives you a little bit more of a detailed view. Normally it would show how many cycles the battery has, how many charge and discharge cycles, but I guess either the software is not compatible with the way that the battery records that, or the battery itself doesn't record that. One thing I did notice, and I don't know if this is entirely accurate, but this battery serial number is 421. I don't know if that means this is the 400th battery that was made for the Libretto W100 series here, but that's just kind of interesting. So yeah, the battery has been working great. And so that's pretty fantastic. I think the capacity is round about 2 hours. I tested it just using Chrome and Pandora, just to have it, you know, doing something that's moderately modern, just to give a light load on the CPU. The fan does run, you know, at a pretty crazy rate. Pretty much anything you do with the W100 is going to make that fan spin up quite vigorously. So I think the last thing to do is go ahead and wrap up the battery and get the case, the top cover of the battery back on, and call this a successful mod. Okay, so first I'm just going to go ahead and plug it back in. I'm going to go ahead and shut it. It should go into standby. I'm just going to let it go into standby instead of shutting it down entirely, just because it takes a little bit of time to get booted back up. Okay, so it just went into standby. So we'll go ahead and remove our battery. And I went ahead and taped down the cells with some double-sided sticking tape. So the cells are now firmly in place. I also taped down the temperature sensor with some Kapton on tape. And so I think this is all ready to go. I also cut a small piece of cardboard to act as a bit of a spacer so that when the top cover goes on, it just firmly holds the cells in place and that the top cover doesn't have give and just gives everything mechanical strength once again. So let's get that top cover back on. Okay, so yeah, here's our battery, and here's the little piece of cardboard that I've cut as a spacer. The nice thing is that it has a little bit of a give to it, so it'll just apply light pressure to the cells once the case is reinstalled. I think I'll go ahead and move some of these wires just slightly out of the way, and we'll just give them a little bit of a push. I don't think we need a whole bunch of tape to hold everything down. It'll just make disassembling and working on this battery a nightmare in the future. So let's go ahead and get the case back on. And I went ahead and tried to clean up the edges as much as possible, straighten out the plastic a bit, clean up any of the glue that might be preventing this from going back on. So I think we'll go ahead and do that. And the way that this works is there's a bunch of clips, and it probably won't hold as well as it used to, but it will probably still also be a little bit of a pain to remove once it's back on. So we'll go ahead and line it back up with the battery. Let's turn it around so we can get a better view, and it should just go ahead and fit back into the grooves. Okay. Okay, that's mostly together. Looks like there's just a couple that are being a little bit weird, but that might be fine. But overall, that is pretty well back together. Snap down a few more of these clips. Give it a good push on all of the edges. And I can feel a little bit of resistance from the cardboard, but it is not causing the battery to bulge in any way. So that looks like that is perfect. Let's go ahead and get that plugged back into the Libretto. Hey, that's perfect. Go ahead and I believe one of these is a lock. That one releases. Okay, yeah, so that's locked. So it has a lock on one side, and then on the other side it has a release. Awesome. Well, that's our Libretto. Okay, well, I will call that a successful battery swap. So here are those old bulging cells that I will be disposing of properly into e-waste. Again, wasn't able to find exact replacement cells, but we found some that were close enough and appear to be working just fine. It certainly gets this machine working again, and we were able to completely restore this battery without making any exterior damage to it. Certainly none that you can see when the machine is just in normal operation. And battery is discharging just fine over here using battery info view. And well, thanks for watching. If you enjoy this kind of content, I would definitely appreciate you giving a like and subscribe. Certainly have more videos like this in the future. Definitely more things on the Libretto series. This one is not entirely retro, but it is getting on in age. And given that we just had to do a swap of some battery cells, we can expect even modern systems that were modern just a few years ago to suddenly become retro again. So, thanks for watching, and that's that.